Thank you. Hi, everyone. Welcome, and thank you for joining our online Coast to Coral talk series. This is a monthly event that we hold every second Tuesday of the month on Zoom. My name is Shayan, or Shai. I'm an ambassador with Reef Check Australia, and I'm dialing in from the Sunshine Coast in Southeast Queensland. So tonight, we're going to be exploring the awesome world of blue-line goatfish with Louise from Macquarie University, and we're going to look at why they change both in color and pattern in mere seconds. So before we start that, I'm going to just do a quick introductory presentation. Before we get started, I'd like to respectfully acknowledge the Coastal and Mary River Valley First Nations peoples, the Gubbi Gubbi, as well as the traditional caretakers of the land on which I currently reside, as well as those on which we all currently reside. And I have to pay my respects to their elders, both past, present, and emerging. Just a quick little background about Reef Check. If you haven't heard of us, Reef Check is a nonprofit organization dedicated to providing ways for the community to better understand, appreciate, and protect our oceans and marine environments. Our mission is to promote healthy local coral reef ecosystems. We do this by focusing on scientific research, community education, and marine conservation. This talk series addresses community education and conservation as it links the community to renowned scientists and innovative projects such as the one we're learning about tonight. Just a quick bit of housekeeping. Online etiquette, if you can, please keep your microphone muted throughout the talk and your videos off. That'll help with the connection. If you're not on our mailing list, please email seqevents@reefcheckaustralia.org to be added. It's there on the screen. And you'll be added to our mailing list so you'll hear about this event happening every month as well as our other events. Or if you want, just add your email to the chat box and we will add you to the list. If you guys come up with questions as you go, use the chat box, please. It's down at the bottom of your screen, and if it's not showing there, just run into the options and you can turn on the chat box. We're going to be taking questions at the end. Emily will be running our Q&A. She's another ambassador with Reef Check Australia. But add your questions at any point in time into the chat box. No worries at all. All right. Oh, before we start, we're going to take a quick group photo. So anybody who wants to be part of the group photo, we add this to our socials. Please turn on your videos now, and Emily will take a quick screenshot while we all have our videos on. So Emily,
you
just
might have to stop sharing, Shai, unless I can.
Okay.
Yeah.
Yeah. All right. How about that?
Much better. Now I can see everyone's beautiful faces. Okay, smile away. And I'll take another one. We're bound to have someone blinking. Awesome. Thanks, guys.
Cool. Thank you, everyone.
Thanks so much for everyone turning their video on as well. That's an awesome shot.
Very cool. All right. So just a quick poll that should pop up on your screen now. We just want to see where you guys are calling in from. So if you can, just quickly have an answer on that question, and I'll launch a second one right behind it. Awesome. Thank you. And the next one we'll go is just how you guys heard about us. Okay, cool. An even distribution of sources. That's great. Awesome. Thank you guys so much. Okay, so just a couple of upcoming events. We have the Ocean Film Festival coming up. This is tomorrow and Thursday. It's happening at 7 p.m. to 9 p.m. at the J in Noosa. If you guys are interested, It's a series of short films that document the beauty and the power of the ocean. Ticket prices and event information can be found at thej.com.au. You can also head to our Facebook page for tickets, but we'll be there with a stall, so come and say hi. And yeah, it'll be a great event. Another really exciting event that's happening that doesn't happen often is Climate Week is being hosted actually at Noosa this year, and that's going to be from the 21st to the 28th of March. There's going to be a big range of events happening. It's going to start with the electric vehicle expo. They'll have cars there, they'll have scooters, they'll have skateboards and stuff, all electric, and you can test out some of them. You can see who's who in the electric vehicle world. I'm pretty stoked on it, as you can probably tell. And there'll be a lot of other events like Plastic Free Noosa cleanup blitzes and workshops, activities for everyone. So have a look on Noosa Council's website. They have a climate change page, and then the whole program is there with the times and dates of everything. So yeah, it'll be great. Hopefully you guys can join on that. Another upcoming event is Earth Hour. So WWF runs Earth Hour every year. And this is a way to honor our planet and to turn off our lights. If you have a chance to look at a photo of our blue planet at night, it's pretty scary how many lights there are. So it's just a good way to help out the planet and stop our electricity emissions. We're going to be hosting a yoga event with Yogi Gabriella Salmon at Phrygian Beach Community House on the 27th at 6:45. So there's tickets on sale now. Bookings are essential, so head to our Facebook page. You can grab your tickets there. It's going to be a fun event. It is every year. Next Coast to Coral Talk series is coming up. Patrick Burke, also from Macquarie University, within the same lab as our speaker tonight, Louise, is talking about saw shark movements, tagging and biochemical tracers to try to better understand how saw sharks fit into their ecosystem. It's on Tuesday, April 13th. You can register online at the Reef Check website. Just before I announce this, there's also a sea slug census this weekend. And Julie, who is the coordinator for Southeast Queensland surveying, all surveying, she's on the call right now, and she'll post some more details in the chat box. And if you guys are interested, just post on the chat box and Julie will get in touch. But the sea slug census is this weekend. So massive shout out to all the women behind Reef Check Australia and all over the world. Emily, Renee, Julie, Jody, all of you guys in the audience and our speaker for helping to drive positive change in the world. It was International Women's Day yesterday. I think it's really important to recognize women in our society and culture. We need to repair and remove historical and current disadvantages and get more women in positions of power. That's pretty much essential to creating a more just, inclusive, and sustainable world. So a massive shout out for International Women's Day yesterday. Another shout out, which is pretty cool. We were humbled and honored to receive Sunshine Coast Council's Environment and Sustainability Award for Australia Day. That was in January. This is a big win for everyone here on this call, our team of volunteers, our staff, sponsors, and most of all, you guys, our supporters, for getting behind us and this mission. So thank you so much. And yeah, we were really stoked to receive that. If you guys are interested, if anybody's interested in the audience and to volunteer with Reef Check, please get in touch. Southeast SEQ coordinator at reefcheck.com.au. Anyway, if you're interested in volunteering, I'm not sure what the email address is, just put your details in the chat box or private message one of us, and we'll get you involved in volunteering. Yeah, you can also reach out on Facebook, Instagram, what's the bird one? No, Twitter and LinkedIn, just kidding. Cool. So thank you guys to all of our sponsors who are joining and for making Coast to Coral possible. Without your support, we couldn't do this. So all of our sponsors listed there. And thank you to the Coast to Coral team. Honestly, it's been so great working with you guys. Thank you for making this happen. It's not easy to run these events. So great work, everyone. All right, so without further ado, our speaker, Lou, is currently a PhD candidate at Macquarie University. She has a passion for all things marine with a particular focus on the ecology and dynamics of coastal ecosystems. Lou completed her Master's of Research at Macquarie University in 2015. She has published her work in international journals, written for The Conversation, and collaborated on a range of projects from remote sensing to fish behavior. During her PhD, Lou has been working to establish if blue-line goatfish use rapid color change as a communication tool. Her work encompasses visual ecology, behavioral ecology, neuroscience, and community dynamics. Lou's research is important in furthering our understanding of how vision and color signals in fishes may have co-evolved and furthers our understanding of communication systems in the marine environment. So please join me in welcoming Lou. Thank you so much for coming and speaking with us today, Lou. I'll stop screen sharing and pass it over to you.
Thank you very much. And I remember to unmute my microphone, which is a small miracle, actually. Thanks so much for that welcome, actually. Even though I wrote it, it is very hard to talk about yourself and to hear about yourself. I will share my screen, actually, but I just noticed that Brittany has joined us here tonight. Brittany was actually an intern with me. Oh my gosh, it feels like a million years ago, and she was amazing. And since went back to France, so was actually joining us, I believe, from France. Just came in a little bit too late for the polls. So I think
that's amazing.
Pretty phenomenal. So massive welcome to Brittany. If we get a chance, it would be great to get in the group photo, but let's see how we go. So that blew me away, which was really nice. Okay. I'll just minimize this so that I can see my screen. Okay, it's a nice small group of us actually tonight, which I noticed. So I think, Emily, if we do see questions come up, I can probably take them as we go, actually, I think, given that there's so few of us, but let's see how we go. I'm happy for this to be fairly interactive. So talking tonight about a fish can change its stripes and the colour changing goatfish, like we said. I'm from Macquarie University, currently finishing off my PhD, and I am so close I can taste it. So talking a bit tonight about why these goatfish change colour, I guess a little bit of my journey in my PhD, obviously not all of it, and lots of videos and lots of pictures of goatfish. All right, and that doesn't work. Okay, so in terms of, actually I was going to do a quick poll. Let's see if this works before we do this actually. So goatfish knowledge, let's see. Do you know what a goatfish is? And unfortunately, Brittany's going to know exactly what a goatfish is, but answer that for me. I'll launch a poll. I've got to do that. I know which buttons to press here. Okay. It's a fish. Okay. No. Oh, look, people know it's a fish, which is good, actually. So we have, I don't know if you guys can see that. 5 or 6 people who know it's a fish, 6 people who know it's a fish, 1 person who doesn't, which is totally fine. Nobody said it was a hybrid between a goat and a fish, and I wish you had, because my next slides will make some sense for you. Okay, I think that's everybody, but everybody knows it's a fish, which is awesome. Okay, all right, so I'll stop sharing that. Does that work? Okay, all right, so what a goatfish isn't. This is a goat, certainly not a goatfish. Similarly to this guy, actually, and my beer that I'm drinking at the moment, goat beer, I thought was quite, fitting for tonight. I did Google goatfish actually out of interest, and this came up, which is slightly terrifying, although not that far from the truth, particularly with the species that I look at. So what a goatfish actually is these little fish, and why, I guess the telling real sign about them is these little barbels that come out from their chin and almost look like a little goatee. Okay, it eats with these, it tastes food, it burrows into the sediment that it eats on and sort of feels around for food. So I found this little thing called hipster goatfish. I thought that was quite cute. But goatfish are actually found, there's over 80 species of them. They're found globally. They're found in a lot of environments, lots and lots of them in tropical reefs. So you guys up in Queensland have probably seen them out and about. And they all have this very distinguishing sort of barbels under their chin. What's interesting about them actually is anecdotally is there's reports that a lot of them can actually change colour. My little species is this blue-line goatfish, and its Latin name is Euponychthys lineatus. We will call it blue-line goatfish for this evening, largely so that I don't have to say its Latin name too many times. But this is the blue-line goatfish. Now, I'm from Sydney, and it's pretty much endemic to New South Wales. So lives in coastal areas from anywhere from sort of 0 metres to about 40 metres depth, can get to about 50 metres, and feeds on sediment, but stays quite close to sort of rocky reefs to where it can actually get some shelter. Okay, so I do think they might extend sort of into the right southern areas of Queensland and maybe into the northern areas of Victoria, but predominantly found along New South Wales. So anybody from New South Wales would be able to don a snorkel and get out and look at these guys. And hopefully I can encourage you guys from Queensland next time you're in New South Wales to come looking for these guys by the end of this talk. But what I'm actually been looking at is they have a phenomenal capacity to change colour, and I'll show you a video which will be quite a nice way for you to get an idea of this, and they change colour really quickly. And so this video will give you an idea of what I'm talking about, as well as sort of how they feed. You guys see that okay? Cool. So you'll see he'll come along, he's been swimming, say he, I don't know why, and it starts to sort of burrow in the sediment. The southern Maori wrasses come along to see what's going on, but you'll start to see that really quickly it starts to get these red and white stripes. Different species of goatfish wanting in on the action as well. So yeah, so you see, so that's what I'm talking about with that colour change. And it really goes from that really nice sort of neutral pale whites to that really distinctive red and white colour in seconds. Given that, look, it doesn't seem to be like it's actually camouflaging, it does make it look to seem a little bit more conspicuous, particularly on this bare sand. And I guess what my hypothesis around this is, and I'll just take back this video a little bit, is that when it feeds, it really sticks its head in the sand. Okay, so it's sort of got its head stuck in the sand. Its vision is a bit blurred. My cat is here to join us. It can't see so well, and its body goes onto a 45-degree angle. And I guess what I was starting to wonder is this could be some sort of predator defense strategy, either in I guess keeping predators away or potentially getting some help. So that's what I investigated. But a little bit about colour change itself, and I don't think I'm probably speaking to most people who know this, but colour is often used. I think some of the most common animals that we know or we relate to using colour change or rapid colour change is chameleons. Often use it in terms of predator defence. So I think a nice example is this chameleon under here, blending into this branch, well known for those really rapid colour change capacities. And obviously similar with octopus. And I'm sure that a few of you have seen this video, but if you have already, it's great. And if you haven't, it's really great. So Roger Hanlon, a marine biologist, took this video, and it's a great example of the capacity of octopus to change colour really quickly. So yeah, so that's just those sort of two really key examples of, those animals using that colour change for camouflage. But of course, there's more than that. And animals are actually well known to use that sort of colour change for more than just camouflage. And in fact, chameleons, these African dwarf chameleons, a study was done by some researchers out of the Uni of Melbourne in 2008, and actually found that their capacity to change colour is used in competition and in social signalling. So actually when they're flirting with the ladies, that's actually where they feel that it's actually evolved from, rather than for camouflage. While they might use it for that, it's actually the signalling that it's actually evolved for. And little cephalopods also use this for communication. So these cuttlefish here are called morning cuttlefish. They're found in Sydney as well. This research was led by a professor at Macquarie University, Cullen Brown. And I don't know if anybody's seen this, but this is fantastic. This is a female here with this sort of mottled coloration. And this is a male here. What he's done is split his body in half. So his left side of his body is signaling to the lady, that he's there, and he's a male, and he's, healthy and ready to go. But on the right side of his body, what he's done is he's changed that coloration so that he looks like a female. So any of the males over here on the right-hand side actually think that they're flirting with a female. It's sneaky and it's brilliant, but it just shows the extent that animals can use and do use color change for. My last example, and I'm probably a little bit biased, but this research was awesome. This came out of Duke University on the Caribbean reef. This was Eleanor Caves, who's done a huge amount of work in vision and colour. But this was done with cleaner shrimp. I'll show you this video. You've all seen, you're probably aware of cleaning stations through Finding Nemo or your work on the reef. And what will happen, I'm just going to come back here a little bit actually, is this cleaner shrimp will wave his antenna, and that's a bit of a signal. But what this goatfish has done is he's turned a darker shade, so he's using his rapid colour change or her rapid colour change to signal to the shrimp that actually I want to be cleaned and it's safe to clean me. And so what happens is this cleaner shrimp comes in knowing that it's safe and starts to clean. It's awesome. It gives him this awesome, awesome clean. So yeah, oh, what happened? Oh, my video is resetting. That's all right. You get the idea of it. So yeah, this clear shrimp gives this awesome clean to this goatfish that's used this dark coloration. And what they found when they did this study is that those fish that did turn darker at those cleaning stations were 3 or 4 times more likely to be cleaned, which is really interesting. So goatfish on, that's pretty much the end of it. It's just my video skipping. Goatfish on the other side in another reef are actually using that sort of color change to signal or use it for mutualistic signaling. So it leads me to this sort of question, and apart from that, there's really not much work that's been done on goatfish anywhere and why they would change colour. So it led me to sort of really ask this question, which I led to before, is that why are they rapidly changing colour? And could this sort of red and white pattern that they change to be some sort of signalling tool? So what we did to start to look at this is we did a little bit of goatfish stalking. And pretty much it's goatfish stalking. So we had a bit of a selfie stick, or so the camera was pointed the other way. That pole is about 1 metre long, and the goatfish would usually be about 50 centimetres in front of that. So it let us keep about 1.5 metres away from the fish. We did a couple of tested differences and found that this was a nice distance that allowed us to record some information without disturbing the fish too much. So we stalked a whole lot of goatfish and we recorded them for 3 minutes each. We just sort of recorded everything. And once we were done with that, it was pretty much into the lab to analyse the hours of footage. So we looked at a couple of different things and we recorded a couple of different things, I should say. And the first one was what colour they would turn. So what we were looking at is when was the fish that sort of neutral coloration or when it was white. And then we were also looking at when it was that really dark red stripe pattern. And then what we looked at in between is there's a transition colour, I guess, or sort of a paler red in between that, is that white and that red. But the white and the red is what we were really focused on in this. We also wanted to look, we also recorded what behaviours they were engaging in. So we sort of had a swimming behaviour, which was anything they were off the substrate, off the sand, swimming or travelling from one site to another. The other behaviour we had was this sort of searching behaviour where they're sort of looking around for food with their barbels. They're not really eating anything. They're just having a dig to see if they can feel for something. So that was what we defined as searching. And then eating is when they really do have their heads in the sand. They found something and you'll see here on the right, it digs its head right in and its body goes onto that angle. So there are 3 behaviours, of course, that we wanted to see if there was a relationship with that colour. And the last thing that we looked at, I'm not going to talk too much about this at all, but we do have to consider the substrate or the bottom of what they were feeding on, just to sort of understand if they might be using this for camouflage. So we also recorded if there was sand, if it was sort of patchy algae, or if they were sort of over rocky reef where rock covered in just that sort of entire sponges and algae there as well. So every 5 seconds, we basically recorded with our videos what the colour of the goatfish was, what behaviour it was engaging in, and what the substrate was. I hope that makes sense to everybody. Okay. So what we found, I'm not going to talk about substrate because what we actually found is that there was the substrate and the colour of the fish, there was no relationship whatsoever between anything. There was no patterns. So it indicates that they're not changing colour in relation to what they're feeding on or what underneath is to them. What we did focus on though was their behaviours. Okay, so we looked at sort of what colours they were turning when they were eating, searching or swimming. And what we found is when they were actually white is that most likely they would be swimming. Okay, so most of the time when they were swimming, they were turning or adopting that white coloration, and very little time was spent eating. The dots is the sort of probability, and the bars around it are the confidence intervals. Okay, but we do see that they were more likely to be white when they were swimming. If we contrast this to our dark red colour, what we actually found is that they were much more likely to be eating when they were that dark red colour. And there was very low probability that they would actually be engaged in any swimming behaviour. So that was probably one of the key things that we found from this. When we looked at that pale red coloration, that transition phase, they were most likely, I guess, to be searching when they were that pale red colour, certainly more than they were eating, but there wasn't quite as anything distinct, which suggests that it's a bit of a transition colour anyway. So pulling this sort of together, I guess, first of all, is that feeding position really does put that goatfish into a compromised position. And if you look at this goatfish at the moment, there's no way you're looking for a predator and you can see if that's what's coming, one is coming, and nor could you make a quick escape when you've got your head stuck like that. So it's likely that it's some sort of predator defense strategy. So the question I had was, well, why wouldn't you stay like that all of the time if that's your predator defense strategy? Well, it's likely that there is some sort of energetic cost to changing colour, and particularly using that red colour. Red colours, the red pigments are carotenoids. We don't, much like it says, like vitamin A, we get it from carrots. Animals don't actually make it themselves, so have to synthesize it from their diet. So like we do for vitamin A, and to see well, we need to eat lots of carrots. Goatfish have to do the same, and they get carotenoids from crustaceans, and they get a lot of from their diet. But you don't want to be wasting it all the time on changing colour. So they're only doing it when they need it, really. So I guess maybe what I'm thinking is that they're using that white colour when they're travelling around, when they can see where they're going. If they need to make a quick burst to get away from a predator, they can do that. But when they're in these positions and their head's in the sand and there might be perceived threat, that's when they change that dark red pattern. Okay. So, quick show of hands from everybody. Is everybody doing all right? Does that make sense so far? Emily, you can let me know. All good? Thumbs up there. I think we're okay. Oh, good. Thumbs up. I can see a few thumbs up. Look at that. I'd minimize my thing. Okay, right. So that's what the actual goatfish is doing. So next we want to do it, like you could see in that initial video I showed you, is that we get other fish coming in and we call them follower fish. And so what we want to try, no, that doesn't work. I'll do that. What we wanted to try and understand was, when are those fish coming in? Are they responding to a particular behavior? Are they responding to a color? So we looked at what was happening there, used the same videos, and every 5 seconds would record what other fish came in. So we looked at things like how long they'd spend around that sort of focal goatfish, and then what their sort of behaviors were in relation to color. So the first thing we looked at is we looked at follower goatfish, because I guess we want to know is, could this be a signal to conspecifics or to the same species, to other fellow goatfish? So what we first looked at was how long they spent. So what we have up the top here is that focal goatfish and its behavior. So whether or not it was eating, whether it was searching, or whether it was traveling. Now I'm trying to not get too much into the science here, and I'll just give you the key things you need to take away from these graphs. So focal goatfish, what it was doing, and also what the focal goatfish color was. So while it was eating, was it dark red, pale red, or that white color? Now, if this was a foraging signal to conspecifics, you'd expect that you'd see goatfish, follower goatfish, spend a lot more time around that fish when it was dark red. And while there might be a little bit of a trend there was actually nothing significant or statistically significant to suggest that there actually was. So the colour of the focal fish wasn't really influencing the time that other goatfish spent around that focal fish. What we did find is those follower goatfish spent a lot more time around those fish when they were actually searching for food. So when those little focal goatfish were doing that burrow and they were looking for food, that's when other goatfish were coming and spending a lot more time with them. Okay. What I also wanted to look at though is, of course, what the follower goatfish, what their sort of behaviours were. And I wanted to look at that in relation to that focal goatfish colour. So we have the colour of that sort of focal goatfish. Again, don't worry too much about the details. There's a couple of key things to take away. So the focal goatfish, whether it was dark red, pale red or white. And then we've got these follower goatfish behaviours down at the bottom. So what we actually found is that the follower goatfish, whether they came in, they came in and travelled, wasn't really affected by the colour of that focal goatfish, and nor really was it if they came in and were attracted. Should probably point out as well that we didn't see any of those follower goatfish actually come in and eat next to the focal goatfish. But what we did see is they came in and showed a bit of attention. So we looked at that as status of behaviour. What we did find here is that those goatfish that were coming in and spending time with those searching fish, they were actually more likely to search for fish themselves when that focal goatfish was dark red, certainly more than they did when they were white. Okay, and that's probably the takeaway from this. So summing up those couple of things. So what we actually found is that the follower goatfish, I've got to move this so I can read this. The follower goatfish were spending more time around those focal fish when they were searching. And this could be a process that we call local enhancement. And we see local enhancement in things like schooling fish and non-schooling fish. And it's when animals are using behaviour to provide social cues to other fish about the potential of food. They use things like darting really quickly, or body positions or things, and they're communicating where that good food could be. And maybe there's something in that searching behaviour that's telling other goatfish, hey, there might be a food patch over here, come over here. What was really interesting is we're not seeing, is that when those other fish would actually start to forage, is actually when that focal fish was dark red. And it might be some sort of indication of foraging success. So we know in guppies that they will look for other fish and they will use behavioural cues to indicate which fish is actually the successful forager. And then they'll follow that one around, which is a bit clever. So maybe these goatfish are doing the same. They're actually waiting to see which fish has actually found food before they actually search in that area themselves. It's an area that definitely needs some more exploration, and I probably need another PhD. So for that so far, that's some of the ideas of what we found. I also looked at some of the other follower fish that came in, so some of the other species. And for the purposes of this talk at the moment, I've really only focused how much time they spent. But similar to the graph you saw before, we have the focal goatfish behaviour if they were eating, searching or travelling up the top here, and then the focal goatfish colour. But what we actually found here is that those other follower fish were spending more time around those focal goatfish when they were dark red and searching and dark red and eating, okay? This was really cool. This suggests that that dark red or that colour change might be some sort of foraging signal, and they might be doing it for a safety in numbers approach. And when I say that safety in numbers approach, a predator is much less likely to come in and attack a group of fish together, as opposed to one soloy. It gives fish extra vigilance as well when you have someone looking out. So it may well be that they're actually doing that for. Every time I press next, it doesn't go on. So what do we know so far? So we know from the first part of this study, I know that that darker red coloration is more likely to be adopted when the fish are eating and have their heads stuck in the sediment. We've learned that potentially there might be some sort of social learning through local enhancement and foraging success going on there with conspecifics or other goatfish. And we suspect it may be some sort of foraging tool by what we're seeing, foraging signal or communication tool by what we're seeing happening with those other species of fish and the amount of time that they're spending around them. What we don't know at this point though, and what I didn't know, is whether or not fish are responding to the red colour that could be the signal, or are they responding to that pattern and is it looking black and white, given that a lot of fish actually can't see red, particularly in sort of deeper areas. So that's what we wanted to explore next, and I guess that's the next part of my talk. First of all, how are we doing for time? I have no idea. Are we all right?
You're doing really well. I do have a few questions.
Great.
If you wanted me to pop them through now.
Let's do it.
Awesome. Okay. I didn't want to interrupt. I didn't think
No,
you
this is
wanted
a
to
nice
hear my
segue to
voice
the next
over that.
part.
Yeah.
Good. Go for it.
Okay, so Shai was just asking about their primary diet when you were speaking of that earlier.
Yeah, well, I think this is the other reason they're called goatfish, actually. They seem to eat anything. I'm yet to do a stomach contents analysis, but goatfish are just, they eat polychaete worms, they'll eat crustaceans in the sediment. They're carnivores, so they will eat most things in the sediment or in the benthos there. So they're benthic carnivores. So yeah, they're not overly picky. I haven't done any preference diet stuff on them. I haven't looked at that. Assuming that they're needing the red coloration, I'd say that crustaceans would be their favourites. But I suspect they eat everything. Does that answer that?
Definitely, yeah. So Marie had a comment that she sent through that I'll pass on. It was when you were discussing the focal behaviours. And Marie mentioned that maybe the noise was from the goatfish digging in the sand.
That's a really, yeah.
I'm assuming that's popped up before.
Yeah, and it's a really good point, Marie. And it could also be, look, goatfish are known to have follower fish, and there have been some studies in reef areas or the Caribbean reef as well about the fact that it's the sediment disturbance that's causing that as well. So they do often have follower fish. You're right, it might be that sort of acoustic sound. It might be the sediment plume as well. So we were trying to tease that apart. And I think that with that seeing, where is it? Where's my plot here? Let's just go back quickly. I think the fact that actually, if it was just the sound or just the sediment plume, then you'd expect with those follower fish to see no difference with that dark red. That's the only thing that I think this teases out a little bit, that it separates that out. There's something going on with that dark coloration. So they might be still using that sound. It might still be attracting them, but I still think they're more likely to maybe go over and actually spend some time with them with potentially that dark red, because we see them spending significantly more time when they're doing that, dark red and eating or searching. Does that make sense, Marie? It's funny when I can't see people.
And of course, as you'd suspect, there's a couple of questions about colour.
Yeah.
Pablo, I've got a thumbs up from Marie there, so
Great.
All making sense.
Great.
Pablo's asking, have you observed them trying to change colour to camouflage from predation?
You know, it's such a hard one. No, I haven't. It would be definitely something that I would love to do. Is trying to witness predation is difficult. They didn't seem to be affected by us. Obviously, we're not predators to them. I'm actually not entirely sure what their predators would be. Assuming it's things like wobbegongs, maybe the little ones, some other predatory fish. So no, I actually haven't. It's a good question though. One of the things I didn't talk about is, while it does seem to be that colour does seem to attract other fish, it might be twofold. They might still be using that colour change as some sort of dazzle camouflage. They are doing that on bare white sand, and it is definitely making them more conspicuous from a human perspective, and I guess that's the other thing. But like zebras use, those stripes, sometimes that is used as actually sort of a dazzle camouflage potentially with them when they move. If I have time, I'm hoping to sort of model that just to see from predator vision to see what that would look like. But I haven't actually seen any predation events in the wild. That would be cool.
Yeah, that would be incredible.
Yeah.
Okay, well, we have a few more questions there, but I'll let you get back to it,
Sure.
and we can pop them through at the end.
Okay. Does everybody, so the next thing, like I talked about, was just looking at, so we've sort of established that there might be these behaviours. My next thing was to look at how we sort of try and tease apart the red and the black. Are we keen to keep going? We're good? Everybody's good? Okay.
All good.
All right. So the next thing that we wanted to do, and I'm to be fair, I'm still not entirely sure if this is one of the most ridiculous things I've ever done as a researcher, and you guys can fill me in, is I did want to tease apart whether or not it is the red colour or the black that fish are responding to. So basically made some model fish to look at this. So we built some red, some black and some white model fish to try and tease apart whether or not it's the colour red that is the signal, or if it's the pattern that's the signal, or of course, when you're going to put some model fish in the water, you also need to allow for control, or is it just interest in that 3D model fish? And so I guess our question was, you know, looking at were there differences in those, the fish abundance and behavior in response to those different goatfish colors. And I'm not going to go through this extensively, probably mostly because I will feel like I've been talking for hours. But I will give you some of the key findings that I thought were kind of cool from this. But just this study was actually kind of fun, ridiculous, but fun. So we first of all modeled a goatfish to scale. I didn't do this. My brother is a talented motion designer, thank goodness. And we took exact measurements, and he was able to 3D model me a replica goatfish, which I then got 3D printed, and I then painted and designed into the different color morphs. I don't have any white ones here, and I'm actually not sure. I obviously just thought they didn't make the cut in terms of coolness, but you get the idea. So we had 3 white with 3 red, and we had 3 black fish. Okay. So what we then decided to do was go out and deploy them. And we deployed them sort of from Sydney down to Eden, all in sort of coastal areas. We had, I think, what did I say before I looked this up? I had 15 sites. I did the math before, along these different sites. We basically built a little apparatus, a remote underwater video or a RUV. The camera went at one end here, the GoPro went here. This was just made of PVC and some weights, so we could bury that under the sediment, and you'll see some pictures in a minute, some video. And we could put that goatfish on top of the sand in that sort of 45-degree angle, so it looked like it was feeding. So what we did is we went out to a different site. At each of these different sites, we picked some reef. And this is always confusing when I do this with people from Queensland. So this was rocky reef. Coral reef would have been a lot nicer. So we did this at some rocky reef. Goatfish don't seem to move too far from those rocks. So I think while they feed on the sediment, they don't want to be too far away from reef for that security, obviously, and for that protection. So usually I haven't actually done that. I'd love to do that as well. That would be another study, but that's a question for later. So we only put these sort of about 2 to 3 meters away from those reefs where we usually see goatfish feeding, put them in similar habitat, randomly put them down, dived down, dug them right under the sand. So it just looked like there was a little goatfish feeding, turned the cameras on and left them for an hour. At the end of that, collected the cameras. I think at the end of it, we had 135 hours worth of footage that I got to go back and analyze and score in the lab. So the counting began. What we did with this is we identified 3 different behaviors. And one of them was with these models is if other fish, we recorded every fish, I should say, that came into the screen, and we recorded its behavior. So we recorded how long, if it passed by. So if it swam by that model and it didn't take any notice whatsoever, we recorded it as passing. If the fish came in and physically looked at that fish, it was definitely, we classed that as an attraction. And if it sort of swam and changed distinctive direction towards our model fish, we also counted that as an attraction. And the last thing we did is obviously if it fed within the vicinity. And I know that's a hard one, but as long as we could still see that feeding fish's eyes clearly, we counted that as a feeding site near our model goatfish. So we had passing, attracted, and feeding, and we looked at that against our 3 model fish. I think the easiest way to give you an idea of what this looked like and to show you some of our greatest hits from this is to just show you a little video I made, which I'll play Oh, again, lucky you guys. Okay. So a couple of things that we looked at and found. I put this together this afternoon. So, I think my heading's gone from this. That's okay. So one of the first things we did was we actually wanted to look at other goatfish and what was happening with them, because I guess there's two sort of ideas or questions here. Is this a signal to conspecifics or other goatfish, or is this a signal to other species of fish, or could it be both? So we looked at other goatfish first of all. So the different coloured models, the white, the black, and the red, and then the behaviour of those goatfish. And what we actually found is that there was really no interaction between the model colour and the goatfish behaviour, which we might have expected, but we didn't see that at all. We did see more goatfish feed around our 3D model fish, and certainly more than they were attracted to. So they would come in and feed near that model fish. And we also saw that overall, the goatfish were interacting significantly more with those black and red models than the white ones. But actually, what was probably more interesting for me than the goatfish, and funnily enough, I think this probably does have something to do with the fact that they weren't moving. If I got to do this again, I would definitely have robot fish or moving fish or something that made the sound, to Marie's comment earlier, because I think that was a really important thing that was missing here. But what we did look at, I guess the other thing that we looked at was two things. We looked at interactions, but then we looked at how much time fish came and spent with those models. And I looked at all of the fish, or the most common 10 fish. We had, I think, about 63 different fish in total over our entire study, but some of those were rare and came in a couple of times. So we had some main offenders, and I've just presented some of the most interesting results here, I guess, is that the silver biddy, little silver biddy that we saw a lot with those goatfish, came in and spent significantly more time around those black models than those red and white models. And what I do know, what I've read up since, is that the silver biddies do share habitat with goatfish. They actually feed in similar areas on sandy habitats just outside of the reef. They don't fight for food at all. They have very different, apparently, food requirements due to this guy has these jaws that come out and can get other stuff. So they can share similar habitat. So it's likely, it's potentially even that there is some sort of looking for safety in numbers or some predator protection. And given that it was around that black and white model, it's highly likely that it can't see red. And a lot of fish actually can't see the colour red. They don't need to, so marine fish particularly. But what we found with the juvenile snapper and the rough leather jacket is that they were around this red fish more. Now, I can't speak to the rough leather jacket, but what was really cool with these little juvenile snappers, they turn into quite bigger redfish, actually. But when they're juveniles, they spend a lot of time in the same habitat as the blue-line goatfish. And there's been some studies to show that they actually have a similar sort of range, and they'll extend quite far out if they're together from the rocky reef. So it indicates that there's some sort of potentially safety with them. But what was extra cool is doing some research into these guys is that when they are juveniles, is that they do have the capacity to see red. So they have a pigment with that long wavelength light pigment there. So actually able to do that. So it was not surprising actually that these fish were spending more time around that red coloured model in those habitats. It was just like, yeah, you're safe, you found good food, I might come out and spend some more time with you. The rough leather jacket, we found the same. I have no information at the moment on what colours it can see. It's quite difficult to test an animal's colour, potentially a fish. I have done that, but that's for a different talk. So I thought this was quite nice and probably did tease that out a little bit. And I do think there's probably definitely something going on with that pattern that is attracting those fish. And most likely probably that black model. I think if I was to do this more extensively, I might find that, but it was really interesting with this juvenile snapper finding. So I think that goatfish might be using colour change as a foraging signal. It's probably likely that fish are using that stripe pattern. Fish, there's a lot of research to show, particularly in the marine environment, the fish do use stripes to indicate health, to mate, to advertise they're good to other fish. And even the black stripes probably, especially in this model, were probably more attractive to a lot of fish that especially couldn't see the red. because they're probably providing that better contrast. And even if you are turning red, if you have a deeper red, it probably shows that you are a better forager. It probably shows that you're a healthier fish. You've got more carotenoids. You're better at looking for food. And so actually what we're seeing in those blackfish is actually you've got a really dark red. You look really good. Why is this all important? Here's some other greatest hits from my my little videos that we put out, our little spy cams. This all sort of ties in, I guess. Understanding how fish communicate is really important into understanding that evolution of sociality. I love this stuff. Like I said to the guys earlier, it'll never get me a job, but gosh, I love it. But I also believe that understanding animal behavior, it's really vital in understanding how a system works and then understanding those subtle changes that might happen. So having these baseline data is really important. This is what happens when you spend too much time working with goatfish. You then turn into a goatfish, but I have had a phenomenal amount of help, as you can imagine, doing this. And so thank you. I am on Twitter, shameless plug, and my lab group, Marine Ecology Group, we do have a lab site. We do some fantastic work as part of that lab. And that's basically it. So questions and chat, really.
That was brilliant. Thank you for that, Louise. I just want to check, is that a universal dive signal for goatfish?
Which it is now.
So we can use that? Okay.
I don't know if it is, but it certainly is in our group now. When we go dive, you should see us hunting for goatfish. It's the most ridiculous thing in the world. So yeah, so that is pretty much our signal. But yeah. So.
I imagine you are the experts for hunting for goatfish. Is that, I saw on your sites that they range from, well, your sites range from Sydney to Eden. How far do the goatfish range north? Do you know their range extension?
Look, according to, I've only got information from Department of Primary Industries in New South Wales. And so, you know, they pretty much say they're an endemic New South Wales species, but I would suspect they probably sneak up a little bit into north, but I don't think all that far. They're not a tropical species at all. They're temperate. Yeah, they're a temperate species. I don't know if climate, look, there's not a lot of work that's being done on these guys at all, you know, which is, you know, yeah, it's nice. But yeah, so.
No, that's brilliant. We'll have to keep an eye out on the Sunshine Coast then.
Yeah, you'll have to let me know if you turn up. Oh my God.
So if anyone sees a sighting, we'll need Marie's, or Louise, sorry, contact. I've got some awesome feedback from your 3D models and your spy cam footage. There was a lot of love going out for that.
That was, yeah, it was really nice.
It's awesome, yeah, and the collaboration between your brother as well. That's really cool to hear.
Yeah.
I have a question from Karen, and she's asking, do they change color at night like some other fish?
They do. They actually do. And I've sort of, that's something that I sort of go to in more detail. But we looked at this really in the daytime when that red light was available. But we have spied on them once. I'm hoping to write a little sort of commentary about it. But they were that sort of dark red color at night as well. So I definitely think they use it for some sort of camouflage in different circumstances. But interestingly, in the day when that red light's available, I think they're potentially also using it for signalling. What's come first, like those dwarf chameleons that I talked about early on, where we've always thought that, you know, they're using it for camouflage, but actually why it's evolved is for something else, but they're actually also using it for that. And there's a couple of fish out there that use their color change for twofold purposes. So yeah, so what came first with this? I wouldn't be surprised if the goatfish are using it for some sort of camouflage, particularly at night. But yeah, but I think they might be also using it for signaling in the day.
Right, okay. And Karen, who asked that question for you as well, is saying that she's definitely seen goatfish up in Queensland. So maybe they're a different species.
Oh, yeah, I wonder. Be interesting. It wouldn't surprise me. There's a goatfish that, the bar-tailed goatfish that sort of extends, it's mostly in Queensland, and they don't reckon it comes down much to New South Wales, and I've definitely seen it in Sydney a few times. So
right,
yeah,
there you go.
I mean, that would make sense with sort of warming oceans, but yeah, goatfish are pretty hardy though, so it wouldn't surprise me if they head up there a bit. God,
maybe biased.
I would go to warmer waters if it was my that's me.
Yeah, potentially biased there, but yeah, definitely. Marie's a huge fan of your video. She wants another performance.
I can do it.
Absolutely. I think we should end on that one, Marie.
Okay, we'll end on that one. I can go back now, actually.
And Shai's asking about their status, if they're a threatened species.
No, not at all. We don't know any. I mean, to be fair, we don't know anything about them. I looked at a lot of these guys' vision as well. So looked to actually try and understand if they can see the color red. So I did. Actually, Brittany was involved in a little bit of that. We were trying to understand their vision of can they see the color red. So I took their eyes and looked at what they could actually see in terms of visual pigments. And we also did a whole lot of behavioral tests on them. But I remember going to the fish markets to get some fish that might look similar so I could practice on them. And there was a pile of goatfish there for $5 a kilo. I was mortified that they could sell them so cheaply. Oh, no. They're not threatened.
I thought you were going to say a pile of eyes. Which I also imagine there was.
So no, not threatened. But I mean, like, look, we don't know anything about them, but no, they're pretty hardy and they're everywhere, sort of in those coastal areas.
Yeah. Right. Okay. Terry, I might get you to turn your microphone on and pronounce that species name for me. Terry's got a comment for you. Maybe he's not on. Or Julie? No. Okay. We'll pass that. Oh, there we go.
I know the Lineatus has been seen as far north as Bundaberg.
Really?
Yeah. So if you have a look on Atlas of Living Australia, you can see.
Oh, it's up there as well. Bundaberg. There you go. Strange, I haven't actually done that because I guess my question hasn't really been about their distribution as much. It's been about this behaviour. So it's funny what focuses what takes your focus when you're doing this. So yeah, no, that's really cool. Although there's two species actually. There's the blue spot and there's the blue lined, and they're same genus. And the difference in them is the way their head slopes. And I'm not even kidding you. So I have spent hours looking at the direction of which way the fish's head is going to try and differentiate. This is the only thing at the moment. So that's maybe my next project, is to work out a way to differentiate these two species. It's ridiculous. So
I love that. That's always the way in research. Marie's asking, did the wobbegong sharks try to eat the models?
None of our models actually got eaten. I was honestly surprised. The wobbegongs didn't come out. I mean, I think that 7-gill, we did see the scream that I let out when I saw that 7-gill shark coming to our models was so fantastic. They're usually quite deep sharks. And so that came in. I'm convinced he was trying to eat my model. I'm convinced of it. Although I think all of those ones where the Port Jackson sharks have hit them as well, they were mostly with the white models. So, that's a sort of little side project is to look at just that. Is there something about the contrast or the brightness that they're seeing? That they definitely seem to bump into that more, but I don't know enough about Port Jackson's visual systems either. But yeah, that's the one thing I did notice. So yeah, we were down there. The reason I've got so many Port Jackson sharks is I was down there helping some friends of mine. You had Juliana Kadar at this? Have you had? Yeah. So I was helping Juliana with her work a season ago. And so I was in Jervis Bay. So there's a lot of cool animals because I was lucky enough to be in a marine reserve doing some of this, which was great.
Oh, that's awesome. And awesome to hear all the collaboration going on. Yeah. I love that.
Yeah.
So we might take another group shot. Definitely, so that we can get everyone in now. But while we have you, thank you so much for that, Louise. It was absolutely brilliant.
Yeah,
and don't forget before you go to replay your video.
I will. I've got it ready to go.
Yeah, awesome. So if everyone that wants to be in the group shot could turn their video on, or if you don't want to be, just remember that your name is on the screen. You have to. Yeah, there you go. No options here. No options. But no, we really appreciate you taking the time, Louise. That was an awesome talk. Thanks, guys. And it is recorded, and I think that's why we didn't have a few of the locals attend tonight, because they're getting used to the recordings now. So we'll pass that on.
Pass it on as well, because that was really good fun, guys. Thanks so much for having me, and thanks for such good questions. That was excellent.
Awesome. Okay, so Brittany and Amanda, just so you know that your names are on the screen.
That's good.
Oops, 2 seconds. I'll get rid of the chat. Bear with me, guys. Okay. If everyone's, there we go. Everyone's ready. Smile away. I'll take a few.
I think a goatfish beer one. Well, yeah, it does.
Yeah, that's awesome. And one more. Make sure the goatfish beer is up.
Actually, I have the model goatfish. Look, he's on my bookshelf.
Oh, and the beer.
No, I'm not putting both in. That looks ridiculous. No.
Is that maybe too obsessive?
Exactly.
That's awesome. Alrighty. Well, thanks so much for coming, everyone, and stick around for the replay of Spy Cam Goatfish.
All right, let's do that. All right.
And is there anything else you wanted to cover, Shai?
No, that was awesome. Thank you so much, Louise. We really appreciate your time. And sorry that it's later in New South Wales right now. And thanks for staying late with us.
Yeah, if anybody has any further questions or did want to, my Twitter was there, my email, you can get in touch with me through Reef Life, Reef Life Check. So yeah, happy to hear any thoughts or feedback or chats about this. It's really valuable for me as well. And I obviously like talking about them. So all right.
That's awesome. And we will pass on all the awesome feedback in the group chat for you too, Louise.
Thanks, mate. Perfect. Thanks, guys. All right. Greatest hits. All right.
That's awesome. Thanks so much, Louise. And there will be a recording, so there can be endless Goatfish Spy Cam reviewing.
It'll be on Twitter as well at some point. Don't worry. Probably next
I hope so.
Yeah, did we see the group shot, said Marie? It'll be on socials?
Yes, I will send them to Jodie and she'll probably pop them up on the Reef Check socials, and we'll also send them directly to you, Louise.
Perfect. Thanks so much, everybody.
Thank you, Louise.
Right.
Thanks everyone for joining.
Thanks, everybody. Thanks, Brittany.
Thanks,
That was amazing. Thank you. Great talk.